Okay, welcome back from the demos. I really hope you liked it because at least I did. That was very nice. Thank you very much, all demo givers, organizers, and deliverers. I don't know how to say that. Thank you. That was very cool. And as a very gentle organizer, I put myself to the worst part of the agenda right after the break. And not just the break, but really a break full of exciting demos. And now I have to bring you back from this beautiful world of real-life demonstrations to slightly less entertaining world of presentations. But I will try to do it as painless as possible. Okay, and maybe to make it a smooth experience, like this transition, I would try to bring you back to 2017 when we started this project. And you've seen that in several presentations today, because yeah, it's always nice to see where we started from and where we arrived to. So I would like to bring you back to 2017 during our kickoff meeting, because it was actually very nice end of spring, and we had very beautiful summer in front of us, COVID-free, unrestricted travels, and people could, I don't know, meet, hug each other, have a drink, and without wearing all those masks. That was very beautiful. But also, we had another feeling that added up on the top, that we had a very exciting and cool project in front of us. So, and to finish this dive into 2017, I did two things. So first, I even shaved my beard, so I look a bit more similar to the image that I had at that moment. And second, I copied the slide from the presentation that we had given during that event. This slide was presented by Sophie during the kickoff meeting, and here it's basically a summary of what we wanted to achieve and how we planned to do that. Just a short reminder. So what we wanted to have nice, reliable channel to drones. We had planned to achieve decent throughput and nice latency. We've seen some problems, and the main problem was interference, because higher up in the altitude you have better channel to many base stations, and interference is indeed the main issue, at least as we perceive it at that time. And potential solutions of that problem was I broke it. And the potential solution that we thought about was first multi-technology, using multiple technologies to boost reliability and throughput, but also we were really hoping for 5G, because at that moment 5G was not really formalized and was not exactly clear what it could be, but we already had an idea that beamforming, when you Akhil shown that partly, when you focus power towards user, you can make it more efficient. You don't send information in useless direction. You focus your power towards intended user. That is one thing that we knew about 5G. And the second part that we knew is that we are going to use different frequencies, namely sub 6 gigahertz, what we mentioned during the demo, and millimeter wave, what we've seen during the demos. And looking back from 2021 to the starting point, yes, we can achieve quite nice reliability with 5G, even with 4G to some extent. But 5G will help us to achieve nice throughput and decent latency. And indeed, our conclusions, our feeling and our conclusions coincide, interference is a very important problem. But apart from interference, we are going to have some other additional problems when we solve the first one. And I think now we are moving towards the decision that understanding that handovers are going to be the new interference, the new issue that we have to solve to achieve even more reliable communication that we have now. And also what Achille shown during his demo, beam tracking. So actually when drone moves, you have to keep focusing the power on the moving drone. This task is very important and also very difficult because you need to continuously sense the channel and adapt the radiation pattern of your antenna. And yes, the enabling technologies that we were indicating, namely beamforming or MIMO and millimeter wave frequency band, are very valid. So how did we came up with these solutions, with this understanding? So I understand that mostly I'm presenting now to companies, so many theoretical things are irrelevant for you. So here I'm just focusing on the contributions that we have. So first thing, okay, tell me contributions to OmniDrone. First thing, we changed the name during the project. Now we are WaveCore, and well, I just wanted to mention it so that you're getting acquainted to the new, very important brand in Flanders, WaveCore. That's us nowadays. And okay, how we started drawing those conclusions. As proper scientists, we started with math. We formulated mathematical models for signal, for interference, coverage. We had those very elegant and beautiful mathematical expressions that, of course, could not provide us with perfect information, with exact numbers on the received signal strength and communication quality, but they could give us understanding where the problems are and where which are the factors that could influence this performance. So I understand that yes, these things are kind of irrelevant for companies. So I'm not going to show all those huge equations that we had, but the ones who attended the tutorial in 2018 and 19 could see that. In any case, these expressions gain quite some attention from the academic community because they can give you some insights and understanding of the potential problems and can help find potential solutions. To move one step closer to the real life, we created realistic simulator, and we already presented a few works based on that simulator, of course. We have to say that this simulator was continuously updated and getting better and better. So the current version of this simulator includes real terrain surface. It includes buildings and other infrastructure. We also have real positions of base stations, real locations of base stations, antennas. We use state-of-the-art channel models to model the propagation. And we also included drone mobility, which was not as straightforward as it can seem. Yeah, even the first version of our simulator contained the first two. We could have real base station locations, but it was a bit more manual. We had to go to the IPT website, we had to check the files, etc., etc. At the moment, it's much more automated, much more fast, and now we can simulate much larger environment than we could do it before. And also antennas, we are using a bit more advanced models at this point. And we can do both 4G, 5G. If you imagine what 6G is, we also can do that after some modifications of the simulator. And we used that simulator and mathematical models for several case studies, which are probably relevant for industrial audience. So that further in this presentation, I'm going to focus on this. The first one, these are the case studies. The first case study is multi-operator diversity. Unfortunately, Frederick left, but it was actually inspired by the proposal that we wrote together with John Matrix. It was called Six Network, as he mentioned in his presentation. And one of the parts of that proposal was boosting reliability by using networks of several operators. For instance, Proximus, Orange, and so on. What is the idea behind? Since the networks have their infrastructure installed in different locations, it's quite unlikely, or at least less likely, to have problems at the same geographical position on all the networks. So if you combine in a smart way signals coming from different operators, you can boost reliability, you can boost throughput, you can do many things. And okay, that sounds logical, and intuitively it should work, and the only thing remained is to check if it actually works. So what we did, we virtually implemented the modem that can connect to several operator networks, and we flew over Leuven, right? Yeah, through Leuven. So here you can see the examples for different altitudes, but that's how the maps assignment maps behave for different operators, operator 1 and 2. As you see, the patterns are somewhat similar, but they're not exactly the same. And that's just proves our intuition. And these are the results. We can achieve 100% coverage up to almost 60 meters, I guess. So for using 3 operators. When you use one, already at the altitude of 30, 40 meters, you'll start feeling the drop of the, reliable coverage. Of course, these results are taken for the worst case scenario. So in real life, that is going to be a bit better. So even for single operator, you can fly up to maybe 50 meters and have quite reliable connection. But if you need very reliable connection, multiple operators can help even for quite high altitudes. Yes, of course, for higher altitudes with single operator, you have less and less probability of having nice coverage. But for multiple operators, it remains pretty high, between 85–90%. We also concluded that antenna configuration has a very important influence on the probability and on different performance metrics. And yeah, another thing that we had nearly no connection loss due to handovers. In this case, when you have 3 networks, handover happens only if all 3 networks have a handover. But that is quite unlikely because of the topology difference, so that the smoother transition is possible. So the second study, it's actually quite symbolic that Klaus entered at that moment, because it's about edge computing that he mentioned and that he actually demonstrated during his demo. Edge computing is when you cannot have enough computational power on board, so you basically send information on the ground, and okay, on the ground you have more power, you have like electricity, you have more computational power, and you can do more things. So in this paper, in this study, we actually checked how this offloading is going to work in 5G. So we had drone and camera, which was flying from point A to point B. We had a base station equipped with edge computing processing. And well, the path was unknown. The path had to be found by the drone autonomously. So it's based on SLAM, which is done on the base station. on the base station side. Yeah, and the SLAM output are used to improve the communication quality. So in this case, the better communication becomes, the more you can offload, the faster you can find the path, the faster you can fly, the better your communication can become. So this is kind of somehow becoming a circle. And these are the results. So basically, if we're using SLAM to understand and to predict channel quality, we can go 20% faster. And so here you can see the different trajectories made by drones. So the dashed one shows just SLAM-based path planning without taking into account communication quality. And it takes this number of seconds to perform to make the path. But if you are understanding where your base station is, if you understand how to improve the communication quality, you can fly in a slightly longer path. This is the comparison, but you can do it much faster because you can offload more data, you can process more data, you can do it faster, and you can complete your mission faster, though with some longer distance. But this longer distance is actually very close to the optimal one when you have absolutely all information, not reconstructed on the drone, but the complete map. So here the drone is relatively smart and can do many things fast enough. And the third study that we performed is actually inspired by one of our talks during the meetings, OmniDrone meetings. So we had an interesting question: can drone-mounted base station help to assist Tour de Flanders? And in this case, what do we have? We have a lot of mobile users. For instance, it can be motorcycle with a huge camera that is driving before the cyclist and making a nice broadcasting product. But then we have this very high definition video to be sent to the broadcasting operation center or something like this, or to actually the broadcaster and show the event in real life. I confused the slides. This is the one that describes the problem. And yeah, so how we can do that? We could try to do it with normal base stations, but the practice shows that the base stations installed on the ground are unable to do this. So in this case, we can put a small base station on the drone, fly not that far from the motorcycle, and okay, the motorcycle in this case is going to be the user, which is communicating with the base station on the drone, and the base station on the drone receives information from a terrestrial base station. This is possible if we're using several technologies which already exist and which are already even standardized. So one of them is integrated access and backhaul. What it means that the same frequency and time resources are used for backhaul, so for communication between base station and the core, and for access network, so communication between base station and the ground user. And this scenario will be definitely enabled by using beamforming, so focusing the power towards your user, and millimeter wave frequencies will help since they provide higher throughput. So actually this solution will be possible only when we go a bit beyond 5G. So somewhere between 5G and 6G, we will have something of that kind, much cheaper than we have at the moment, because at the moment they're using helicopter for very similar solution. Okay. This presentation has kind of circular composition, so I'm going to go back to the main contributions of WaveCore to OmniDrone, and I removed the math part. So we have this simulator that can do many things, and we performed many case studies which gained some attention from academic community, but also we are really happy that these case studies are motivated by our conversations with industry. And here is my message. If you want to use the simulator, we are ready to do that. But if you want to help us improving it, then we are really happy. If you have facility to measure the channel, put user on the drone, record power, etc., so that we can actually use the real life data and compare with our simulator and make everything much better than it is now. We are quite confident that it's good, but there is no limit for perfection. So if any company has this ability and this desire, we are ready to do that. And also new case studies. If you have a very interesting, novel application in mind that you don't know if it's going to work or not, contact us. We can try to set collaboration and define what we can do. Thank you very much. And this is end of my talk. Thank you very much.